9.5, the sine and cosine ratios. Essential question, can I use the sine and cosine ratio to find unknown sides of a right triangle? Let's take a look at this triangle. We can see we have an angle and we have an adjacent side, but we don't have an opposite side, so a tangent ratio is not going to be able to be used here. We do have a hypotenuse though. With this information, we're going to be learning how to use a brand new trig ratio, and that's called sine and cosine. Now, the sine is actually spelled like this, but we just use the first three letters. Cosine is spelled like this, but we just use the first three letters. The sine of A is the opposite leg divided by the hypotenuse. The cosine of A is the adjacent leg divided by the hypotenuse. All three ratios can be learned using a mnemonic. The sine is the opposite leg over the hypotenuse. The cosine is the adjacent leg over the hypotenuse, and the tangent is the opposite leg over the adjacent leg. Let's go ahead and put this mnemonic up for this problem so that we can refer to it. Now they're asking us to find the sine of S. Sine of S. And S is opposite, so here's S, and the opposite leg is 63, and the hypotenuse is 65. The sine of R, it's a different acute angle. The opposite is 16, and the hypotenuse is 65. Now let's find the cosine of R. Now here's R, and cosine is adjacent leg, which is 63, all over hypotenuse, which is 65. Notice that these ratios are the same because we're using the same sides of the triangle. The cosine of S, and here's S, is the adjacent leg, which is 16, divided by the hypotenuse. And it's happening again because we're using the same sides of the right triangle. So let's take a look at this sine versus cosine. When we take the sine of 22, the sine is the opposite over the hypotenuse. And when we go to the other acute angle, which is really 90 take away 22, then the cosine is the adjacent over the hypotenuse. So using these two acute angles and finding the sine of one and the cosine of the other will yield the same sides. This is called sine and cosine of complementary angles. When A and B are complementary angles, the sine of A is equal to the cosine of B, and the cosine of A is equal to the sine of B. Let's take a look at this problem. The sine of 56 degrees. We want to write that in terms of cosine. Remember that if we allow this to be 56 degrees, this is going to be the opposite, and then this is going to be the hypotenuse, which is what sine is. For cosine, what we're going to do is we're going to work with the acute angle. So we're going to take 90 minus 56, which is going to be 34 degrees. So the cosine of 34 degrees, here's 34, adjacent, which is B, over A. So the cosine of 34 degrees is the same as the sine of 56 degrees. The two acute angles that are complementary, cosine of one is equal to the sine of the other. In your homework, you're going to be asked to do problems like this. Write the expression in terms of cosine. So this will be equal to the cosine, and again, you have to make sure it's the complement, and the complement will be 53 degrees. For this particular problem, if we want to write the expression in terms of sine, we're going to do the sine, and remember, we have to work with complementary angles, and so this will be 31 degrees. All right, let's go ahead and use our new trig ratios to help us find x and y. Again, I'm going to start off by writing my mnemonic, so I have all my rules in front of me. And I'm going to work with 26. So I'm going to say sine of 26 is equal to the opposite, which is x, over the hypotenuse, which is 14. If I make it look like a proportion, and then I cross multiply like this, I'm going to get x, and you can see I've already put it in my calculator, and we're going to round to the nearest tenth, so this will be 6.1. Now let's work with the cosine of 26, and the cosine of 26 will be the adjacent, which is y, over the hypotenuse. Make it look like a proportion, and you're just going to multiply these two, which I've done in my calculator, and so y is approximately 12 point, now here's the tenths place, but because the next door neighbor is over 5, we round it to 6. Okay, now it's your turn. Stop the screencast and see what you can do. And here are the answers. So I used the mnemonic SOHCAHTOA to help me identify the opposite and the adjacent and the hypotenuse, put them in the appropriate places, and then solve. Let's find the sine and cosine of a 45-degree angle. So I'm going to find the sine of 45 degrees, and I can just pick this 45, which is opposite, which is 1 over root 2. Now we want to rationalize it, so I'm going to write root 2 over root 2, and so the answer is root 2 over 2. So this is the sine of 45 degrees. Now remember that the cosine of the complement, remember these are complements right here, these two, they are going to be equal to each other, and so that's going to be root 2 over 2. If you forget about this sine and cosine relationship with complementary angles, you can just go back to the triangle and use the formula. Okay, your turn. Find the sine and cosine of a 30-degree angle. And here's the answer. We can leave it in exact form. That's what this is, exact form. That's the sine, that's the cosine of 60, or you can write it in its decimal form. Okay, your turn. One more example. Go ahead and find the distance the skier travels. Stop the screencast and see what you can do. The appropriate trig function to use was the sine, because we have the opposite and the adjacent. We go ahead and set it up. You can make it look like a proportion. Now what I wanted to do is exchange places here before I actually used my calculator and found the value. Now it says round to the nearest foot, so that's why I didn't go to the tenths place. And this is the end of the screencast.